Hello and welcome. Today we are going to tackle a topic that, let's be honest, trips up a lot of people: directed numbers. We're going to crack the code and make positive and negative numbers finally make sense. You know that feeling, right? You're staring at a problem like -3, and it feels like your brain just short circuits. If you've ever felt like these numbers are playing by their own secret set of rules, trust me, you are not alone. But I promise there's a really simple logic behind it all. And today, we're going to uncover that logic together. First, we'll look at how numbers actually have direction. Then, we'll take a little walk on the number line to practice adding. After that, I'll let you in on the big secret to subtraction. We'll cover the super simple rules for signs and then wrap it all up with a final cheat sheet you can take with you. So let's get started. All right, so the very first big idea you have to get your head around is this. Numbers aren't just about how much of something you have, they're also about which way you're going. Think of every number as a journey starting from 0. So this is the official definition. A directed number has two parts. The first is its magnitude. That's just its plain old numerical value, like 5 or 10. The second part is its direction. And that's what that little plus or minus sign is telling us. It's basically a command. Go right for positive, or go left for negative. And you can see it perfectly right here. +3 means a journey of 3 steps to the right of 0. -2? Well, that's just a journey of 2 steps to the left. It's the same basic idea, just in opposite directions. Okay, let's put this whole direction thing into practice with addition. Honestly, the best way to get a feel for this is to imagine we're literally taking a walk along a giant number line. And the process is always the same. First, you find your starting point. That's just the first number in the problem. Then, you get ready to move a certain number of steps. That's the magnitude of the second number. And here's the crucial part. You move in the direction of that second number's sign. Wherever you land, that's your answer. So let's see this in action. We start at +2, we're adding a +3, so we just take 3 steps to the right, and boom, we land on +5. Simple enough. But what about adding 2 negatives together? No problem. We start at -3. This time, we're adding a -2. So that means we move 2 units in the negative direction, which is to the left. 2 steps to the left from -3. And that puts us squarely on -5. See? The exact same logic works every time. Okay. Addition is pretty straightforward. But subtraction, this is where things can start to feel a little weird. But don't you worry, because the aha moment is right around the corner. We are about to learn a secret that turns every single confusing subtraction problem into a super simple addition problem. I mean, look at this. This is the classic brain melter right here. How in the world can you take something away from 2 but end up with 5? It just feels wrong. But I promise you, it is 100% mathematically correct. And to understand why, we need to talk about one key idea. And that idea is the additive inverse. Now that sounds way more complicated than it is. It really just means the opposite number. So the additive inverse of +5 is -5, because, 5 plus -5 gets you back to 0. The opposite of -10 is +10. You get it. And here it is, the secret, the key to everything. If you remember just one thing from this entire explainer, please make it this sentence. Subtracting a number is the same as adding its opposite. Burn that into your brain. This one rule unlocks all of subtraction. Okay, so let's take a problem that might look a little tricky. -5 minus +2. Using our old way of thinking, this is confusing. But using our new secret rule, this is going to be a piece of cake. We just follow the rule. Step 1, change that subtraction sign to an addition sign. Step 2, flip the second number to its opposite. So +2 becomes -2. And just like that, we don't even have a subtraction problem anymore. Look at that. We've turned that confusing mess into a simple addition problem that we already know exactly how to solve. We're at -5 on our number line, and we just add -2, which means we move 2 steps to the left, and we land on -7. This secret works. It's that easy. Now, if you thought that was cool, you'll be very happy to hear that multiplication and division are actually even easier. They follow 2 very simple, very clear rules. And here they are. It's this simple.
Rule number 1. If the signs are the same, so 2 positives or 2 negatives, your answer is always positive. Rule number 2. If the signs are different, one of each, your answer is always negative. That's it. That's the whole thing.
And here's the best part. You don't need to memorize a whole new set of rules for division. Nope. The exact same logic applies. Are the signs the same? Your answer is positive. Are the signs different? Your answer is negative. This just simplifies things so much. Let's just run through these real quick to see the pattern. -6 times -2, well, the signs are the same, so the answer is positive 12. +5 times -3, the signs are different, so the answer is -15. And look, the exact same pattern holds true for division. It's really just about spotting if the signs match or not. Wow, we have covered a lot of ground, right? From the idea of direction to the secret of subtraction and those simple rules for signs. So now let's pull it all together into one final powerful slide. This is your complete toolkit. And here it is, everything you need all on one screen. For addition, just think about walking on that number line. For subtraction, remember the magic phrase, add the opposite. And for both multiplication, times, and division, it's all about the signs. Same signs as positive, different signs as negative. That's the whole system. So, there you have it. The code is officially cracked. Directed numbers aren't some big, scary mystery. They're just a logical system with a few key rules that you now know. So the only question left is, now that you've mastered this, what's the next level of math that you're ready to unlock?